And welcome, everyone. My name is Pani Kendeu, and I am one of the co-directors of the lab. And it is a distinct pleasure and honor to introduce today's speaker. And we are really excited to have with us Dr. Menzcer. He's the Ladi Distinguished Professor of Informatics and Computer Science and the director of the Observatory on Social Media at Indiana University. Phil is joining us with his group today to give a talk, and then we will have a demo of some of the tools that they have developed at Indiana University. He holds a laureate in physics from the Sapienza University of Rome and a PhD in computer science and cognitive science from the University of California, San Diego. Dr. Menzcer is an ACM fellow and a board member of the Indiana University Network Science Institute. His research interests span web and data science, computational social science, science of science, and modeling of complex information networks. In the last 10 years, his lab has led efforts to study online misinformation spread and to develop tools to detect and counter social media manipulation. He and his colleagues are doing some of the most innovative and cutting-edge work in this space. And again, I'm really excited to welcome Phil and looking forward to his talk today. Phil.
Thank you, Bonnie. Thank you for having us. I will give a presentation about an overview of the work that is going on at our observatory. And then three of the students in our lab, I think I see two of them already have joined, Matt and Kevin, and then a third will join later. Kristen will give some demos and overview of some of the tools that we develop and the work that they're doing with that. So let me share my screen here. And the work that I'll present will be around ways that the mechanisms of online virality in which information spreads online on social media can be somehow manipulated, can be hacked. So let me start by showing you this picture that is the kind of object that we study in the lab. We look at diffusion networks. So in these networks, nodes are accounts, social media accounts. Let's say Twitter, for example. Most of the work that I will show will consider data from Twitter. And you can see that some nodes are larger, some are smaller. That's sort of associated with influence. For example, if a node is retweeted by many others, then we could use that as a proxy for its influence. So the links in this particular picture represent retweets. So, you know, if I retweet something posted by Pani, then there is a link between the two nodes that represent our accounts. And so the size of a node here is proportional to the number of connections, which is the number of retweets that a node receives. This particular network represents the diffusion of one particular piece of content, which is this fake news article that you see at the bottom. This was a completely manufactured, fake, false news claim that it was one of the most popular ones that was spreading during the 2016 elections. It came from a well-known conspiratorial site, InfoWars, and it was a precursor of current QAnon types of conspiracies claiming that the Clinton campaign was involved in satanic rituals. And so a picture like this shows how many people are sharing this piece of information, who are the major super spreaders, who are the most influential nodes that are spreading it. But we could also look at, for example, whether some of these accounts are suspicious. You can see that these nodes here are colored, and the red nodes are ones that we believe are automated. They're not automatic accounts, they're fake accounts that are just trying to expose more people to this content. So I'll talk more later about these, what we call social bots. So this is one particular piece of information, one piece of content, and this was very popular. It was shared by over 30,000 accounts. Now you can look at another article, and it may be shared by more or fewer people, and you can look at a lot of different content from low credibility sources, but also from credible sources, for example, fact-checking accounts, and you can look at what is the distribution, the statistical distribution of popularity of this content. And you get these curves that you see on the top left. These are broad distributions. So you can see on the x-axis, they span many orders of magnitude. What does that mean? That most pieces of information, including low credibility information, are not very popular. They're seen by very few people. But there are a few that get incredibly popular, that are seen by very large numbers of people. And this is a typical signature of virality that we observe on social media, these broad scale distribution. And what's concerning here is that the distribution for low credibility content is even broader than the one for credible content from fact-checking sources. So how is it? What are the factors that affect virality? What are the factors that lead some content to become very, very, very viral? So we've tried to study this question by building some agent-based models. These are very, very simplified model of the world, and by world I mean our social media ecosystem, where we throw away a lot of details and we try to keep some of the salient characteristics in order to study specific phenomena. So for example, we might retain the structure of the social networks that we get from follower relationships or for retweet relationships. We might consider the fact that people can post new content or they can retweet something that appears on their screen. We may account for the fact that people have limited attention, so they don't look at everything that is posted by their friend, but maybe only a subset. And we can consider that people can post original content or reshare something that was posted by their friend. So these are some of the simple ingredients that we could incorporate in this kind of model. So once we do this, and we run simulations of these simplified models, we found that there are two ingredients that are sufficient to explain these virality patterns, this broad distribution of popularity. One is the structure of the network itself. So if the network is random, then we don't observe these broad distributions. We don't see that stuff goes very viral. But real networks have hubs, and they also have high clustering coefficient, which means lots of triangles. So you have a community structure where lots of your friends of your friends are also your friends. And so when we have networks with these characteristics, then that leads to these viral patterns. And the other ingredients is limited attention, like I mentioned a moment ago. If you assume that people will look at everything that is posted by their friends before choosing something to retweet, then you don't observe that a few things will go higher viral. But if you assume that people only look at a few of the things that appear at the top of their screen, then you do. So these are two very important ingredients: the structure of the network and the limited attention. And both of them can be hacked. So that's what I'll be sort of organize my presentation around: ways to hack the network itself through echo chambers, and ways to hack our attention by manipulating our engagement. So let me say just a little bit about mechanisms of diffusion online. So the ways that ideas and opinions and information travel on social media is transmitted from person to person on a social network is not quite the same as the way that a virus, for example, is transmitted from a person to the next. So in biological epidemics, we talk about simple contagion, which means that every time that there is a contact between two people, with some probability, an infected person can infect another person. And that probability is the same for each contact. When we talk about ideas and behaviors, however, we talk about complex contagion. And what does that mean? It means that the more times you're exposed to some idea, the more the probability increases that at the next encounter, you will adopt that behavior or maybe reshare that content. So here, each contact is not independent of the previous context. Each contact builds upon the previous content. And why is this related to the structure of the network? Well, it is related to the structure specifically of communities. How? Well, inside a community, we have lots of triangles, okay? We have this property called clustering coefficient in networks. So that means, friends of your friends are also your friends. So what does that mean? It means that when one person reshares something from somebody else, now there are two people who have shared that same piece of content. But because those two people are involved in many triangles, they have many common friends, now there are many people who all of a sudden are exposed to two. And for every increase of another person who adopts that behavior or meme or reshares that piece of content, there are many, many, many people who are now exposed to more instances of that behavior, of that content. And this is called social reinforcement. So it makes it easier because of complex contagion that something spreads very fast inside the community. The other ingredient of the structure of the network is homophily. These clusters generally have to do with some content. So the reason like you're connected to somebody is because you have very often something in common with them, maybe your political leanings, for example. And so if something spreads inside the community because that community is vulnerable to or interested in that piece of content, then very likely everybody else in that community will also share that interest. And so both of these points connected with the idea of complex contagion mean that things spread very, very fast inside social communities, within social communities. In fact, if you look at lots of different memes, for example, identified by hashtags, and you look at those that spread very virally, let's say more than 1,000 times versus those that are not viral, you see that the number of exposures before somebody decides to reshare that meme is different in the two cases. So for the majority of memes that are not viral, people have to be exposed several times. This is the black curve here. Whereas the most viral memes, people are exposed very, very few times, kind of like in simple contagion. And so this gives us something to identify an ingredient of virality. So things that are viral are the ones that do not stay embedded inside the community, but spread very fast across community. People can share it even when they see it only once. So communities can help things spread very, very fast inside the community, but they could also work as boundaries, keep things from spreading from one community to the next, because there aren't so many triangles, across two different communities. And so in simple contagion, we expect to see weak concentration inside communities, whereas with complex contagion, we expect to find strong concentration inside communities. And what we find is that, again, different behaviors for the most viral tweets. In that case, memes tend to have low concentration inside communities, whereas in the majority of cases, memes that are not super viral remain mostly concentrated inside communities. And so this suggests that if you can detect whether something is staying within a community versus spreading across communities, then you can sort of predict whether it's going to go viral or not. And that turns out to work. If you can look at, for example, the first 30 tweets of a particular hashtag and look at how these 30 tweets are distributed among different communities, you can predict whether this hashtag is going to go viral or not. So if initially it is spread across multiple communities, then it is much more likely to become viral. Whereas if initially it's mostly concentrated inside one community, again, even though the total number of tweets is the same, but if it's more concentrated, then you can predict that it's not going to go viral. All right, so this is some of background information about structure of online communities that helps us understand virality. Now, what are the communities that are out there and that often affect misinformation and online abuse? Well, if you do some simple clustering, for example, among people who share news on Twitter, whether you look at the follower network or whether you look at the diffusion network, you immediately notice a very, very clear separation into two large and dense communities. We call these echo chambers, because people are much more likely to be connected to other people inside that community than to be connected in the other community. And these communities are very strongly aligned with partisan political partisanship. So, in this particular case, on the right, you have conservatives in red, and on the left, you have liberals in blue. And furthermore, the size of the networks in this picture is actually proportional to the fraction of links that are shared by a particular user. Again, these are links to news sources. But some of these news sources are low credibility sources, those that post junk science and conspiracy theories and fake news and so on and so forth. Well, the larger the node, the more that account shares links to low credibility sources. And we find that there are some of these very large nodes, especially inside these echo chambers on the right and on the left. So one question that emerges is, what is the role of social media in fostering these echo chamber structure, these segregated and polarized communities? So to explore these questions, we built a model just like the one I showed you before, but now users can also change who they follow, okay? And so there are two major ingredients in this model. One is that you have some opinion and your friends have some opinion. And if you're exposed to people posting their opinion or that is sufficiently close to yours, then they can influence you a little bit. You can change your opinion a little bit. That's social influence. And the second one is, like I said, the links can change and through the mechanism of unfriending. So if somebody post something that you strongly object to, that you very strongly disagree with, let's say you find it offensive, you might say, okay, I'm gonna unfriend this person. And in this particular model, in that case, the link that is cut, which is showed as a dashed line, is replaced by a random link. So you follow somebody else at random. Now, initially, people have opinions, which in this case are captured in a very simple way, like one-dimensional, right? From blue to red, progressive to conservative. And you can see that over time, people unfollow, right? You can see these dashed lines and then replace those links with, with random ones, the solid lines. And you can notice two things. One is that the opinions are changing. Initially, we had that distribution of opinions across the full spectrum, but through the process of social influence, you see that the colors are kind of becoming more narrow. So you have the blue nodes and the red nodes. You don't have that breadth of colors anymore. And what is also happening is that the network is sorting itself out. The people are sorting themselves out into communities, right? They're more likely to unfollow somebody that they disagree with. Therefore, they end up being more likely to follow people that they agree with. And so over time, we see both of these phenomena. We have polarization of the opinions around these two poles, the red and the blue, and segregation of the two communities where people are most likely to be connected only to people that are similar to themselves. So there's much less diversity here, and you're unlikely to be exposed to ideas that are different from your own idea. So this is what we call echo chambers. We have we have less access to a diversity of opinions. And this is a simulation that you're welcome to play with. It's available on our website, and you can play with different parameters and find slightly different behaviors. But generally speaking, what this shows is that when you have both social influence and rewiring, then the sorting of the network into these polarized and segregated groups happens much faster, orders of magnitude faster. Then you have either segregation or polarization in the presence of social influence only or rewiring only. This idea of echo chamber is also something that we observe in the wild instead of just through through these models. Not only at the aggregate level with the echo chambers that I showed you earlier, but also as an account sort of navigates through the social media ecosystem, most people find themselves into echo chambers. So to explore this behavior, we ran an experiment where we created a bunch of inauthentic accounts, bots, but they were honest. They didn't, impersonate humans, and they were absolutely identical, doing very simple things like following people at random, retweeting things at random, and they all followed exactly the same random behavior. So which was completely neutral. They don't understand anything that they see. Okay, they have no notion of politics or anything like that. But the difference between these accounts is it's just one, okay? The very, very first account that they follow, okay? So when we created these accounts, the very first thing that they did is follow one news source. And some of them follow a left-leaning news source like The Nation, some of them follow a right-leaning news source like Breitbart, and etc. There's 5 of them that you see here. And except for that one first following action, everything else was completely automated. We left these bots alone. It did not intervene in any way for several months just to see what happened. And what happened is that the ones that started on the right find themselves in conservative echo chambers. The ones that started following a left-leaning news source find themselves mostly in liberal echo chambers. There are a few exceptions. Look at this one, for example. This started following the Wall Street Journal, but at some point it started following CNN, and then it kind of leaned left. But this is kind of like the exception that confirms the rule. In most cases, the accounts that started on the right drifted even more to the right. The accounts that started on the left drifted slightly towards the center. So there was actually a conservative bias in this environment. But here is another interesting picture. When you look at these echo chambers that these accounts find themselves in, you notice some interesting patterns. Here, the yellow nodes are the bots, okay? These are our neutral bots. And the color represents the, the political alignment of a subset of their friends and followers. So you can see the ones in blue, and then you can see the ones in red. And then the size of the nodes represents, again, the fraction of misinformation, low credibility sources that our neutral bots were exposed to from these other accounts. And so you can see that there was definitely a higher incident of low credibility content on the right. And here's a picture of that at the top. The accounts that started on the right or center right were exposed to higher volume of low credibility content. Furthermore, both the ones that started on the left and the ones that started on the right found themselves in groups with higher clustering coefficient. That's what this transitivity is, which means basically that they were in dense groups with lots of triangles, what we call echo chambers. Now, so this suggests a vulnerability to fake news, to misinformation that has been reported by others on the conservative side. But what we find is that it's not only on the conservative side, it is stronger on the conservative side, but it also exists on the left side. So when we look at large volumes of tweets over many months of data of everybody that posts links to news sources, we find that people that are more partisan, both on the right and on the left, are more likely to share low credibility content. Okay, so how can we hack these networks, these echo chambers? Now that we know that the echo chambers are themselves vulnerable, right? Stuff spreads very fast inside an echo chamber. And we know that accounts find themselves naturally in these political echo chambers. So how can I exploit that? Well, one way to exploit it is with so-called trains, okay? You may have heard about these follow trains. It started out very innocuously with Follow Friday idea, where people would say, hey, follow these friends. And then now actually it is something that is being abused by political follow trains. These exist both on the left and on the right. You can see an example here, examples here of this kind of political train tweets. What is a train tweet? Is a tweet where an account lists many other accounts and is basically saying to its followers, follow these people, follow these accounts. And this can be done. Other accounts then can simply automatically follow all of these accounts. And doing this means that everybody follows more people. And because everybody follows more people, they can also be followed by more people, because Twitter puts a limit to how many people you can follow. If you don't have at least 5,000 followers, you cannot yourself follow more than 5,000 people. So this is a reciprocal process where everybody follows everybody else. The network becomes denser, bigger and denser. And so now you have this enormous echo chamber. So we look at the structure of these follow train networks. And we find that it's very hierarchical. You have this very dense core where you have these nodes that basically broadcast lists of accounts to be followed. And they are very influential, and they also post a lot of low credibility content. So the plot on the right here, sorry, there's some plots here. I don't have time to go into the technical details. I'll just summarize what's the main message here. The one on the right says that if you look at how many followers an account has before they are mentioned in a train tweet and after, you see a big boost. So I think, if I remember correctly, the median number of followers increases by 600%. So this method is very, very effective. And in fact, you can see that the conductors, the accounts that generate those tweets with list of people to follow, have grow their friends very, very, very fast. They grow the number of followers. New friends. They follow many people very fast. So hundreds per day. And the ratio between the friends and the followers is very, very close to 1. This is because what I told you earlier about the fact that Twitter has the limit that you cannot follow more than a certain number of people until you have yourself enough followers. So these accounts always stay around the ratio of 1, because as soon as they have more followers, then they follow more people. So that's about hacking the the network. Now about let's talk a little bit about engagement, our finite attention. So again, we have models where we try to look at what are the consequences of the fact that that there is finite attention. So imagine this is a model similar to the one that I showed you earlier. In this case, however, the network is static. It's not changing. What we observe is that people share content, and this content can have low quality or high quality. Again, this is a model, so we can draw quality from some distribution. And let's imagine that you can tell the quality of the stuff that you see in your feed posted by your friends, and you're more likely to share memes with high quality. Okay, so let's say that the probability of sharing a piece of content from a friend is proportional to the quality of that piece of content. So among the things that you see, you are going to more likely share good quality content. So in this case, you expect that there will be a correlation between quality and popularity, right? Because the higher the quality of something, the more people will share it, so therefore it'll go more popular. So in fact, that is what you observe as long as the information load is low. In other words, there isn't so much content so that people are able to see most of the stuff posted by their friends. This is scenario on the left. Here, the size of a node is proportional to the quality. And so you can see all of these are kind of like big fat nodes. This means that this is good. People are mostly sharing good stuff because they can see most of the stuff posted by their friends. And then they can see, okay, this is bad, I'm not going to share it. This is good, I'm going to share it. And so you find a very high correlation between popularity and quality. But as you move to the right, what is changing here is information load. So now everybody posts more content, okay? And because these agents have limited attention, because there is more content out there, the fraction that they see on their feed is smaller, okay? They're gonna go through the feed, and then with some probability, they're gonna stop after a while. So a lot of the content they don't even look at. And so in this case, even though everything else is the same, the only thing that changes is this information load. In this case, the correlation between popularity and quality goes way down. And so what you see on the right, in fact, is that a lot of nodes are very, very small. This means people are sharing junk. Again, these are agents that are trying to do the right thing. They're trying to share, to reshare good things. But just because there is so much junk out there, they end up also sharing a lot of junk. So the overall quality of information in the system goes down. So here is another, in that model, we were not assuming that the platform was doing anything with ranking, okay? We were just assuming that people were seeing things in chronological order, okay? But we've all heard about, what about engagement bias in algorithms? So in fact, most social media platforms, they don't show you things in chronological order, they re-rank them, right? They try to predict what you're going to be engaged in, and they're more likely to show you that because they want to keep you on the platform to make money from ads. So here we added this ingredient to the model. Here we assume that the content that you see is ranked by an algorithm, okay, by the platform. And we assume that this algorithm can tell to some degree the quality of the content, but also can measure the popularity. It knows how many people have shared a piece of content. And so we look at a family of algorithms that have some mixture of these two ingredients. That's captured by this x-axis, the probability of selecting mean by popularity. So when it's 1, it means things are strictly sorted by popularity. When it's 0, things are strictly sorted by quality. And then you have some mixture of them in the middle. And we do know, by the way, that platforms have quality signals that they could use, but sometimes they give it low weight because it results in lower engagement, right? So what you see here is a very clear pattern that the more the algorithm weights engage, oh, sorry, I went back to that mistake. The more the algorithm gives weight to popularity, the lower the overall quality of the content in the system, okay? Now, there is a little bit of an exception here. Let me point you to that. So for some value of the attention, the parameter that I showed you earlier, or information load, whatever you want to call it, a small amount of popularity bias can actually help, okay? So you see that this yellow becomes a little bit brighter. So what that illustrates is the idea of the wisdom of the crowds, okay? So the algorithm can pick up the fact that some users have focused on higher quality content and then say, oh, if a lot of users like this, then I'm going to show it to other users because they might like it as well. This is the idea of the wisdom of the crowd. And it works in a very narrow range. As long as people have just the right amount of attention and the algorithm has just the right amount of popularity bias, then you might have a very small advantage, okay? But this is small and narrow, okay? In general, this engagement bias tends to suppress overall quality in the system. Okay, so this is now from the point of view of the platforms, and I mentioned that platforms have availability to some quality signal. So to show you just one example of what these signals might be, this is a study where we looked at the diversity of the audience of a particular news source. And we found, this was our hypothesis, it was confirmed that the more diverse is the audience of a news source, the higher the standards, the quality standards of that particular source. So for example, the Wall Street Journal, which is read by a lot of conservatives, but also by people on the left, has a much higher quality than something like, let's say, Breitbart, who is mostly read by people on the right. And in fact, when we took this quality signal, the diversity of the audience, and incorporated into a recommendation system, into a ranking algorithm, we found that the quality of information that people were exposed to increased a lot. And it particularly increased for those users who used more extreme news diets, more partisan content, and also who consumed more information, and who visited more sources, and who tended to visit more low credibility sources. So basically, all the vulnerability factors were mitigated somehow by promoting content that had a more diverse audience. So this is an example of a quality signal, but platforms certainly have lots of these signals that they could use. All right, so I was talking about engagement from the point of view of the platform, but what about the users themselves? Because when you go on YouTube, it'll tell you, or TikTok or whatever, 20 million people have watched this video. So we are also affected by knowledge of these engagement signals. So how does that affect the quality? So to explore this question, we ran an experiment with an app called Fakey that we developed in our lab. It's like a news literacy app where you see a feed of content, and some of this content comes from mainstream news and some of it comes from low credibility sources, and you have to decide whether to share or like or fact check something, and you get points for doing the right thing. Okay, so in this experiment, we manipulated the engagement signal. So people would see something that would tell them 426 people have liked or shared this. And then we looked at how that affected people's choices of whether to like or share or fact check something. Now, focusing on low credibility content, articles from low credibility sources, the more users thought that had high engagement, that other people also liked it, the more they were likely to share it itself. Again, this is sharing junk. And the more people thought that something had high engagement, the less they were likely to flag it for fact checking. So just being exposed to this number, just that mere fact makes us more vulnerable. Okay, so basically, this creates a vicious cycle because the platforms themselves amplify the engagement, the popularity signal that they get from the users. And the users themselves pay more attention if they see that more people have paid attention to something. So it is a cycle where the cognitive bias of the users and the algorithmic bias of the platforms feed each other, all right? So some things go very, very viral and other things do not. And this could happen by accident, like I showed you earlier, where the platforms might amplify initial stuff just by chance, but it might also be manipulated. And so this is where manipulation of the finite attention comes in. Because if I can create the appearance of some engagement, now I can trick both the algorithms and the users together. And that's what inauthentic accounts do. So we've been studying these inauthentic accounts for a long time. And we coined the term social bots over 10 years ago. So that's when we discovered the first instances of completely automated accounts. Like on the left here, this is a little network with 3 accounts. Orange edge means mentioned, blue edge means retweets, and the width of the edge is proportional to the number of retweets. And so we thought that this was a bug in our code. Why is this super giant edge? And then eventually we realized, no, it wasn't a bug. It's that these 2 accounts are retweeting each other tens of thousands of times. And so we looked at them, and of course, these were the actual first social bots that we discovered, that anyone discovered. And they were promoting this account, which, by the way, was a politician running for the House, a very influential person. And so these accounts were just promoting that by tweeting and retweeting the favorable content tens of thousands of times. This is an example of a coordinated network of bots or inauthentic accounts trying to promote something. So all of these accounts which by the way were fake churches. And they were all created by one person who was running a fake news website. And so this person would post a fake news article, and then all of these accounts would tweet links to that fake news and also mention a user, which is here in the center. And this usually was an influential user, like a politician or a reporter, in the hope that they would retweet it, and then that would lead to a viral cascade. So these were early examples of bots. We have machine learning tools like our botometer that we developed in our lab that help people tell what is the likelihood that an account might be suspicious, perhaps automated. So we wanted to look at the role of these social bots in amplifying low credibility content. So this picture here represents a retweet network for tweets that have links to either low credibility sources or fact-checking sources during the 2016 election. This is a small portion, the core portion of this network. And in orange, we see retweets of fact-checking sources, and in purple, we see retweets of low credibility sources. And you can see another instance of echo chamber, right? The people who are most vulnerable to low credibility information tend to be connected to other people who are also sharing junk. And as we zoom into the core of this misinformation network, we see a higher prevalence of likely automated accounts. So again, if you are in the business of spreading misinformation and trying to get engagement, you can go to vulnerable communities and just share stuff there, and it'll get reshared. And in fact, even our neutral bots that I told you about before, the ones that started following the liberal or conservative or central news sources, when we looked at their friends, who they were following, the ones that started on the left and on the right were more likely to follow automated accounts. And the ones that started in the center were less likely to follow automated accounts. So what can these bots do? What can be their strategies to hack attention? Well, one of them is to target influential users, because everybody pays attention to influential users, whether they're celebrities or Donald Trump or other influentials. And so the more you are automated, the more you're likely to mention highly influential accounts, one with millions of followers. An example of this was this yellow node here, which this is the network of spreading of a particular false claim during 2016 election. This was the claim that 3 million votes in the presidential election were cast by illegal aliens, and that's why Trump lost the popular vote. This was a false claim posted by InfoWars with no source, no credible source, just put it out there. And here in red, we see mentions, tweets that mention other users with a link to this fake article. And in blue, we see retweets. So what this yellow nodes was doing, it was replying to content mentioning Donald Trump coming from all major news sources. So then the reply would mean that in the reply, both Donald Trump and these major sources were mentioned. And then the reply was just a link to this false news article. And these accounts did this systematically, hundreds of times over a long period of time. Obviously, the point was to get the president to see this false claim and somehow get the impression that major news sources were talking about this claim. And sure enough, at one point, the president did repeat this claim and even created a commission to investigate it and so on and so forth. So this is one strategy, is targeting influentials. Another strategy is flooding the network, right? So you can see accounts that share the same link to the same low credibility source hundreds or even thousands of times. And this is something that automated accounts can be used very, very effectively for just getting more people exposed to a claim that way. In fact, when we look at retweets, okay, this is one way to mention impact, right? If humans are retweeting something, then that's a way to have impact. So if we look at retweets of these links with low credibility, links to low credibility articles, most of the retweets come from humans. That's what this plotted, the projection at the top is saying, that if you look at the retweeter is more likely to be a human, to have a low bot score. Now, if you focus on these retweets from humans, who do they retweet? Who was the originator of the tweet that they're retweeting? That's the projection on the left. And you see that most of them are humans, but many of them are also bots. So this is what I showed you in that very early picture with those red nodes, right? So the bots, what they're doing is they just amplifying the message by getting more humans exposed to a piece of misinformation, and then these humans may then retweet it. So how do I hack this system, right? How do I inject content? So recently we learned that one trick is to delete content, because Twitter has a limit on the volume of tweets that you can generate. You can generate up to 2,400 tweets in a day, which, by the way, in my opinion, is crazy. That's way too much. Why should somebody be able to post 2,400 tweets in a day? I think 10 would be good, right? But let's even imagine 2,400 is okay. It turns out that many accounts can circumvent this limit. And the way they do it is by posting and deleting, posting and deleting, posting and deleting. So if you look at the total number of tweets that people post by virtue of posting and deleting, this can greatly exceed the 2,400 limit. In fact, some accounts can post up to hundreds of thousands of tweets per day. Imagine that. Okay, so deletion is one way to sort of to cheat. And because you create more volume, then now you can trick, again, like I said before, you can trick users, you can trick algorithms. And one very specific behavior in which this can be done is not only by posting and then deleting stuff, but posting it, then liking it many times, right? So that the algorithms will think, oh, people like this content, so maybe it'll go trending, or they'll put it at the top of the newsfeed. Now, how would you get many people to like something? Well, it turns out you don't have to. What you can do is you can like something and then unlike it, and then like it again, and then unlike it, and do this thousands of times every day. And so we found these networks. The node in the center posts something, then all of the other nodes around it like it and unlike it many times. And then ultimately the content is deleted. Okay, so this is perfect. I can control just a small number of accounts, maybe 10 or 50. And I can write a script that does this. And now I can push things to go trending, because the algorithm will get the signal that lots of people are liking this. And so we found all kind of junk content using these techniques, for example, to sell stuff for spam, or sell retweets, or sell fake accounts, and so on. And again, this doesn't have to be done just by automated accounts, right? These accounts could actually be human. So here is an example. If I show you this account, you might think, okay, there's nothing weird with this. This is an anti-Trump guy. He has a website, and okay, what's wrong with it? But now if I show you that there is actually a whole bunch of accounts that look very similar, suspiciously similar, right? They're probably created by a script. They use similar images, similar hashtags, and so on. And some of them are anti-Trump, some of them are pro-Trump. So now you would say there is something fishy here. And sure enough, this was a network of accounts that was doing fraud. They were claiming to raise funds, either pro or anti-Trump, and then of course pocketing that. So it was fraud, and eventually Twitter found them and suspended them. But so all these accounts were run by a human. So everything that these accounts posted was not automated. It was posted by a human, but the software is used to control multiple accounts. So if you can control multiple accounts, you can now have impact. You can have an influence campaign. So we're using our models to try to understand how much impact can you have on a particular community. And so, for example, one important factor is how well you infiltrate that community. If you control a bunch of accounts, but those accounts are not followed by many people in that community, and these accounts post, let's say, low credibility content, you can lower the quality of content generated by the community, but not by a lot. But now, if those accounts can infiltrate the community, can get a lot of other people to follow them, now they can lower the overall quality of information in the system. And this is exactly what those trains do. Remember the follow trains? That's exactly what they do. They tell everybody, hey, follow these. Well, if you're pro-Trump or anti-Trump, will say, okay, these are accounts that think like me, I'll follow them. And now you're embedding yourself into this community, and you're becoming even more vulnerable. And we found these kind of coordinated networks everywhere we looked. We looked at accounts that were basically recycling Twitter handles to avoid detection. We found accounts that were retweeting the same content to spread misinformation about COVID, or retweeting similar images to influence the debate about the Hong Kong protests, or retweeting at the same time to spread to run pump and dump schemes for cryptocurrencies, basically for fraud. And then, of course, accounts who would tweet the same content or slight variations of the same content in support of a candidate, very often spreading misinformation about the elections, or even misinformation about COVID. Sometimes these are regular accounts that are hacked. Sometimes they're people who donate their credentials to a campaign that then posts on their behalf. And then sometimes they're people who are paid to post this content, as in the case of a youth group in Arizona that was caught doing this troll farm kind of behavior that we analyzed. And it's not only on Twitter. This is, for example, this is on Facebook, where we find similar highly coordinated networks that spread low credibility content from some sources. And this is in the context of low credibility information about COVID, for example. In the next hour, you'll see a few demos of some of the tools that that we developed. Like I mentioned, Botometer, Botslayer is another one, which attempts to detect coordinated groups of suspicious accounts early on. Like in this particular example here, we found a bunch of bots that were pushing a false news video from Russia. This was a long time ago. And then within seconds, all of those accounts were suspended by Twitter, but our system sort of detected them right away. So we want to make it easier for the general public to become aware of these kinds of abuse. All right, so let me finish here with a summary. What we have seen is that network community structure, complex contagion, echo chambers, limited attention, engagement bias, and herd behaviors all affect online virality, and that bad actors can exploit these vulnerabilities and can hack them either to amplify misinformation or to manipulate opinions. Okay, this is a shameless plug of our textbook. Let me finish here by thanking everybody in our observatory, the colleagues and especially students who are doing all of this work. This is their work, and you'll hear from 3 of them in a minute. And I also want to thank our funders that support our research. Thank you so much. Hopefully there is some time for questions.
Yes, we do have a few minutes. I wonder if, well, Phil, do you want to continue to share your screen, or do you want to see everyone for the question? Okay, great.
Yeah.
Thank you so much. This was amazing. You have given us a lot to think about. We do have time for questions, so if you want to ask the questions, feel free to unmute and also turn your camera on if you want to, and Phil will be happy to answer.
If not, it's also okay to take a short break, because I'm sorry, I realize now that I went a little bit too long. And so
Phil, I'm happy to kick us off. This is David. Thank you again so much for your talk. I just have a quick question. I'm sure you mentioned this at some point in the talk, but I would just love to hear what measure you were using for like the quality or the credibility of the news source. I think it would help me understand how like the claim about more diverse audiences tend to get attracted to high quality. What was that? What was that high quality measure? Thank you.
Yeah, good question. So I tend to mix these things because I talk quickly about lots of different things. So let me try to clarify. I roughly showed two different kinds of analysis. Some were based on simulations and some were based on empirical data. So for the ones based on simulations, quality is a completely arbitrary metric, okay? We just assume that it's a number drawn by from some distribution. So for example, you might imagine that most stuff is low quality and a few things are high quality. So you could just imagine some kind of distribution that has a higher probability for low quality and lower probability for high quality, and we draw these numbers from this distribution. If there are bad actors, let's say, accounts that are controlled by entities that are trying to manipulate the system or spread misinformation, then we could imagine that they're drawing from a different distribution. For example, one where most of their content was low quality. So this is a model, this is a theory, and you can generate your own, you can choose your own distribution in any way that you want to explore whatever question you want to explore. So all of the models that I presented that had a quality, the quality was just like a random number drawn from some distribution. So basically it's a hypothesis that we are making. For the empirical analysis, now in this case, we actually do need some kind of measure. And this is a hard thing to do, and there's a lot of debate in the research community about how to do it. But the most widely used approach is to label things at the source level instead of the specific article or tweet level. The reason is that we just don't have reliable machine learning algorithms that can say this article is low credibility. A very small subset of things are fact-checked. For example, the super famous article from Vasugi et al. From MIT, which showed that low credibility information spreads faster and wider and so on. They used a very, very, very tiny fraction of misinformation that had been fact-checked by Snopes. So we want to be able to do this at a larger scale. And so we don't have any method to label individual tweets. So what we do instead, and not just us, this is most of the studies in this area use the same approach, is to use labels that exist for sources. So by now, there are lots of organizations and researchers who have labeled sources. And for example, they will tell you, Wall Street Journal has a reliability score of 0.9, whereas, InfoWars is 0.1 or something like that. And some of these are freely available. Some of these you have to pay for. And some of these are maintained and updated very often and by professional fact checkers or journalists who evaluate a source to look at whether they cite sources, whether they correct errors, whether they identify sources, whether they don't use images in misleading ways and things of that nature. So that's what we do. We generally look at the source. So if there is a link, we look at this we look at this at the source, at the domain. So for example, CNN.com, and then we get the score for that particular domain. And then we aggregate that at the level of tweets. It's not a perfect method because sometimes a credible source can post something wrong, and sometimes a low credibility source can post something correct. But it allows to do these large-scale analysis and to get some meaningful results.
Thanks so much, Phil, for your great talk. It was very interesting. And I think your finding, the study finding that the correlation between quality of information and popularity of the information is decreasing when the information load is high.
Right.
I think it has really important implication for scientists when they would like to communicate their research. And from your experiences or any from study findings, do you have some suggestions about what would be effective way for researchers to communicate findings, scientific findings to public. Like, for example, the content should not be more than 3 tweets when you reply to yourself. Like, it should be more than 3. Like, do you have like suggestions?
Yeah. Well, I think that's an interesting question. In fact, there was an article in the latest issue. I don't know if I think it was Nature, where they were looking at scientists becoming more proficient, let's say, on Twitter to share their results, and so that means, of course, that you have to adapt to the medium. So in the case of Twitter, that means these days writing these threads. And so, we do that just like everybody else, and it's kind of contributes to the big volume. So, that's an interesting issue that you pose. Do you go along with what everybody else is doing? Interestingly, even very, very reputable news sources have tended to adopt some of the techniques that, that initially were the hallmark of very low quality sources, like using titles. Even the New York Times or the Washington Post now, when you post an article on Twitter or Facebook, the title will be different from the one that you would see in print. So, these kind of techniques that are used to, capture engagement are now becoming completely mainstream. I don't know if I have advice for scientists or researchers to communicate their finding, but I do have a thought about how perhaps we could improve this situation. And this is a hypothesis, something that needs to be tested. And that is that, because part of the problem is that it's so cheap to generate so much information, whether you do it automatically with bots or as a human, or right now you can just tap on your screen and lots and lots of people will be exposed. So it's an incredibly cheap way to create content and to spread content. In some sense, because the cost is so low, I think also the value is low. As the cost of generated information has come down, the value has also come down, because now anybody can post junk, and you don't have to have a degree in journalism or the money to set up a server or the expertise. You can just post anything. So in some sense, that leads to the suggestion that maybe we could reintroduce some friction, make it a little bit more difficult to generate content. We have the old saying, 2 cents, right, from the price of a stamp. Somehow, it's not a lot, but it's something. So what if we introduced a very small cost for posting information? It's kind of like what Twitter does when they say you can only post 2,400 tweets in a day. I think, first of all, you should make sure that it can be abused. And today it can be abused. And second, the limit should be something much more reasonable. Why 2,400? What about 5? And of course, this doesn't mean that you have to pay. We certainly don't want to discriminate, people on the basis of whether they have money or not. But there could be other kinds of costs. For example, we're all used to CAPTCHAs these days. We all accept that in order to log in, we have to punch something on our phone or recognize whether a picture is a bicycle or check a box or something like that. So you could use those kinds of approaches to add friction, to make it more difficult for somebody to either manually or automatically generate huge volume of content. And if there was much less content, then we would be able to look at more of it, and at least according to our models, that correlation would increase.
Thank you.
Well, thank you, Phil, and thank you everyone for joining us.
There is a hand. There is a hand.
Oh, there is a hand. Bodong, go ahead.
Time for one more.
Yes, I think we can do that and just have a shorter break between this and the demos. We can definitely continue if Phil is up for it.
Okay.
All right. Thank you so much, Phil, for the talk. Wonderful work from your team. I have a burning question myself, so I hope it's okay to kind of continue maybe for 1 or 2 minutes. the work you have done has really kind of revealed the complexity of like socio-technical dynamics in those social media environments, and how powerless I feel as an individual, as a human. I could really reclaim my agency, as somebody who lives in society, who consume and produce information. So I feel it's really powerless in the moment. So I'm hoping you can give me some hope. For example, sharing any tips you might have for individuals who are consuming information, who are making decisions based on the information, or if you know any educational programs that are trying to empower our students to be a more literate citizen as they become older. So anything that you can share with us will be much appreciated.
Thank you. That's a really, really hard question. You're putting me on the spot there. I don't know that I have any, any wisdom or advice, but I mean, common sense advice that is shared by a lot of people is, one is like, don't use social media as your source of news. I mean, I don't need to tell you guys this. Of course, you're academics and you're students and you know this, but a lot of people unfortunately do, they use social media as their source of news. And so they're not aware of how biased that is and how much they are exposed to, one type of source versus another in that way. So, it's okay to use social media. I think they're good for many, many things, but we shouldn't use them as our news source. Another point is, don't share something until you've actually read it. A lot of people share things without looking at it. And in that case, we can become unwittingly part of the problem. All of us, we can all be tricked, and we see something based on an image or a title that we feel like we need to share it, and we need to resist that temptation. Very often when you actually read the article, you realize, okay, maybe I didn't need to share this. Maybe because the title was slightly misleading, or the image was slightly misleading, or it is something that hadn't been confirmed yet, and so on and so forth. So, I mean, that's advice about being a good citizen in some sense. That's not exactly what you were asking about, but I think that if you are a good citizen yourself, and you will also feel better in some sense, that you're at least contributing in our own little way that we can all do. We are contributing to making the information ecosystem a little bit less polluted. That probably won't be enough. We need regulation probably, because platforms, of course, have to look at self-interest. So in the absence of regulation, probably they will have very little incentive to invest significant amount of resources into addressing these problems. So I hope that there will be a combination of grassroots, people trying to do the right thing, and also encouraging our policymakers to enact sensible regulation. So obviously, I'm not talking about censorship, but certainly regulations that increase transparency and make sure that platforms enforce the rules that they have. One of the most frustrating things is that sometimes they have pretty good rules, but they don't enforce them. They don't take something down until, let's say, a journalist contacts them about something. Even though in theory it's violating their policies. So I think we all need to, put some pressure on platforms to do the right things, and hopefully we'll feel a little bit better doing that, but I don't know if that's enough to address your question. Thank you. So I want to make sure that you guys have at least a chance for a little break before the next part. I apologize, I have to leave for another meeting, but I'll be back towards the end. And you're in good hands. I know that Chris and Kevin and Matt will do a fantastic job showing some of our tools. Thank you, guys. Thank you, everybody.
Thank you, Phil.
Okay, see you in a little bit.
All right. So let's take a 5-minute break. With that, suffice, and then feedback at 2